Good evening. We are very happy to be with you today. I am Antoine from the 3D department of CGEV. I have the pleasure to share this mic today with Julien, our amazing Houdini technical director, and with Thomas, one of our 3D supervisor. Thomas and I have more background as a rendering generalist. So we will speak to you today about how Houdini became our main 3D software, how we progressively adopted USD and Solaris, and in fact how we made most of our 3D team switching to Houdini in their daily work. Just a few words about CGEV. The Visual Effects General Company, Compagnie Générale des Effets Visuels. CGEV has been founded in 2012 by Alain Carsou. Alain Carsou is known as VFX supervisor and compositing supervisor. He notably worked on movies for directors like Jean-Pierre Jeunet, Luc Besson, on movies like Amélie, Alien Resurrection, Taxi and the Asterix movies. Today we are about 100 people with a main studio in Paris and another one in Angoulême, and we closely work with Peanuts in Belgium. CGEV works on dozens of movies and episodic, both for cinema and streaming platform, and delivers hundreds of shots every year. So, yes. Let's start with a quick breakdown of most major 3D projects from these last years. Okay. Thank you. So about the 3D department, as you have seen, we work a lot on environment extensions, but we also work increasingly on sequences involving effects like sea, rain, snow, fire, and crowd and destruction. Houdini has always been our main FX tool, but before we rendered our FX effects on Mantra and other images and other DCC called Maya. And we spent a lot of time importing and exporting between the DCCs. We didn't have a real true scene assembly solution. So we progressively adopted Houdini. In 2022, we chose to render our first full CG shots on Mantra on the show Asterix and Obelix, The Middle Kingdom. We used a tool Julien just created called Multiplan, Multishot, which allow us to send dozens of renders in one click. Then we worked on Monsieur Aznavour, and we chose to work with Houdini Arnold. And for this occasion, we worked on tools to make the exchanges of shaded assets easier with Maya Arnold. In 2024, we had a project with more than 100 shots to deliver in 2 months. So we decided for the first time to work with Solaris Karma. It was a bit challenging, and Julien will talk to you about this project. But it was a bit risky because we didn't have a lot of time, but it was a success, and we were very happy with the speed of Karma. Then we worked on Le Grand Déplacement, and Thomas will talk to you about this environment focus project. And now we play more and more with Solaris because in USD we trust. So I will let Julien take over with this case study. Thank you.
All right, thank you, Antoine. Okay. So let's talk about Squad 36. It's a movie by Olivier Marchal and distributed by Netflix. My name is Julien Margelin. I'm in the 3D industry for 15 years. 15 years now, and 7 at CGEV. I'm FX artist, TD, in charge of the workflow and some of the tools. I contributed to films like The Substance, Asterix, The Young Girls on the Sea, for directors like Coralie Farja, David Cronenberg, Guillaume Canet, and Jean-Pierre Jeunet, and many others. So let's watch the breakdown of the movie now. Well, thank you. Just a summarize of the adventure for us. It was a 6-minute sequence. The brief was turning the sun into rain, because the movie was shot during a sunny day in Paris. We have 180-60 VFX shots to handle, 2 months post-production with 6 FX artists, 4 generalists, 3 modeling artists, and 1 animation artist. Let's begin by the beginning. First of all, the storyboard. We have to study it with Antoine and identify and anticipate the workload. We notice there is a lot of close-up shots from inside the car and outside the car, who will be a big concern for us. There is a lot of cars. We don't know how many. At the first place, we think there will be 3 cars to handle, but at the end it was many more. And there is also the motorbikes. Sorry. It begins with the feasibility phase. So Netflix gives us the opportunity to make a test. So we have 3 representative shots. We put a small team on it to do intensive R&D, but at the end we have the client approval, and it was cool. So here you can see some of the early flip books we made for the testing. And here you can almost see the rough rendering with a comparison test at the bottom. Move from R&D to production ready setup. Well, it's one thing to handle 3 shots, but it's another to handle 100. So we take all the cleanup who were produced during the feasibility phase. We clean and simplify all the setup, organize the layer. As you can see, there is one net box by FXPath. And everything was exported separately for rendering purpose. So this phase was important. So the artists, when they arrive in the show, they can run the setup on every car easily. So just as you can see, there is 2 main parts in the setup. One for the close-up and one for the mid-range shot. It's a lot of pop simulation who are mesh at the end. There is also a ripple simulation for the body of the car. There is windshield wet map, and the plick block is just the interaction with the body of the car and between the rain and the body of the car. And for the close-up, we had high-res windshield simulation with a ripple, and flip simulation for the wipers. The wipers was not so easy, so during the show there was additional setup path build to handle the FX. Okay, so this is the sub part. Everything is exported into USD format, so we can bring the simulation back into Solaris. Here is one car in Solaris, so all the references are loaded and shaded, and at the end just export 1 layer for each car. Everything is simulated at 0 points, so we can mutualize all the simulation by just transforming them to bring them back to the shot as a good place. So we had to do some shot automatization. Sorry. So this is the sub part. It's based on the shot naming convention and the asset nomenclature from the tracking. We have a template. We just have to copy the template and give it the shot name. Here we are inside the template. The artists have just to run a Python script to populate the template with the good cars according to the shot naming. In this network, we also do the UV camera map work for the environment and the reflection. And also it allows us to generate points according to the camera angle to scatter the rainbox at the good place. Here is just some zoom on some part of the setups. So you have the Python box, the transform for the cars. It's just simple things like we have the race position car, like a fixed car, and an animated car from the tracking. You just compute the transform and bring back the transform to Solaris to move the car. And here is the setup for the rain box. Just a simple free-roam and some multi-scatter tools to distribute all the simulation at the good place. So we have to do a lot of development because it was our first production on Karma and Solaris. We have to rebuild a lot of nodes we already have, but who are needed to the show. So we have based our workflow between Maya and Houdini and Alembic at the first place. So we ingest all the data we need in Houdini and export them, convert them into a USD format. We also have to develop some tools to handle the export from SOP into LOP. Yeah, so we can export USD layer for the rendering team. So here's the tools we develop for SOP. We have the prep cache for cleaning all the geometry, the USD proxy to build a proxy for each thing we want to export to Solaris, and the rob cache to export USD. We also have some features on it, like simulation that dedicate on fast servers, custom wedge system, and distribute rendering for the simulation and the geometry cache. So let's go to LOP now. Here are the nodes we developed for the show. The CG reference with our loader. So we can basically build the network and make export a layer for the other department to make the lighting, for instance. We also have some managers to handle all the cache, and I will present them now. So we have, from left to right, the reference manager who collects every cache who are exported in one place. So we can load them very easily. It can handle the versioning too. We have the same for the layers, so every department can pick the layers they need to make the rendering. And we have the render manager who can collect in one place all the parameters we need for rendering the images. So with this we can handle a lot of shots in one place. Let's talk about the multi-shot system. It's quite a simple HDM. It's based on templates. So graphists have to build templates for the shots with all the layers they need for rendering. They put it in the HDA. They select a list of shots they need to render. Click on the button, and then the multi-shot system takes care of everything. It duplicates the templates and feed it with all the data it needs to render for each shot, and in this case for each car. It's quite simple but powerful. So with the render manager, people can render everything in one click, but if they had to make overrides or custom things, they also have access to the networks. Yeah, it's not so bright, so you don't see anything, but you also see it in the breakdown. Here are some images of the results. So you can see a lot of simulation for the body of the cars. You will see the rains and the work we did on the motorbike for the trails, who are more custom shots. I want to show you also some screenshots I took during the production, so you see them. There is a rock on the ground with noises to fake the rain flow. Little trace for the wheels, the wiper collider who are beautiful, and the body of the car with all the ripple simulations on them. Here you can see the camera map for the reflection. Some of the wiper simulation for close-up purpose, and trail passes for the compositing. And here is a simple example of the motorbike. So how we work. Well, my supervisor Antoine gave me some beautiful drawings in orange, so I can say, okay, it's this direction, it's this size. Give me pictures of what he wants, so we can match the reference and build the velocity fields to match it. Well, it's all for me. Please welcome Thomas Louisor for the next case study.
Thanks, Julien. So I'm Thomas. I work as a CG supervisor at CGEV, and today I'll talk about Le Grand Déplacement, one of the shows we worked on last year. So that's a movie, sci-fi, French sci-fi comedy movie directed by Jean-Pascal Zadi, where African astronauts try to find an exoplanet as Earth is not as safe as now. So to quickly set the scale of this show, we have some numbers. We had to deliver over 70 shots, with around half of them being full CG. We worked with a team of 17 artists during roughly 6 months of production, and during that time, we created and designed 10 CG environments and 15 hero assets. So for a team of our size, it was actually pretty ambitious from a VFX perspective. And Solaris ended up being the main tool that we use to make that happen. So today I will talk about this show being my first time using Solaris in a production environment. We'll see a couple of the different type of VFX we had to handle during this show, and we'll focus more on a specific sequence. That being said, let's jump to the breakdown. So as you could see in this show, we have a main focus on environment and on huge scale environment. So we heavily relied on Solaris instancer. We actually instant everything that were possible to instance. And everything were structured around USD layers. Each department could work individually, but at the same time staying at the same stage level. So that gave us the ability to work at sequence level. If we had a modification, iteration, or retakes on animation or effects or environment, each artist could rewrite their layers, and our assembly scene would update instantly. Thanks to the tool that Julien just presented to you, the multi-shots tool, we were able to work at sequence level and to batch render shots from entire sequences. And that was a major key for us on this show, especially with this amount of VFX to handle. We had shots that combine multiple hero assets, like a space station, spaceship with ton of lights on it. We also had a huge scale space environment. And one of our main focus on this show were the dynamic lighting. We worked the lighting as a second level of animation to bring life to pretty much every shot. So we developed a dynamic lighting setup to create light strikes or to have the starlights slide on assets that were floating in space. And we have one sequence that actually combine pretty much all these different VFX elements. One of the most challenging that we have to deal with, the asteroid sequence. We can watch it in the final movie and talk about it just then.
Elle est où la Terre? La Terre, elle est où? Mais je fais comment pour prier, moi?
Qu'est-ce qui se passe?
Mais si je prie pas vers la Mecque, je suis foutu! Je vais brûler en enfer! Astaghfirullah!
Nous traversons actuellement un champ d'astéroïdes. Négatif, nous avons une défaillance de notre bouclier magnétique, nous ne sommes plus protégés des radiations. Activation du système de protection d'urgence. Là on s'expose, prends des risques, hein, ça tabasse.
So there is a lot of things going on on that sequence. We had a spaceship going crazy fast through an asteroid field, with effects in pretty much all the shots of the sequence. And one of the keywords on that sequence were consistency. We wanted to have a continuity on the lighting and on the environment through the different shots. So we worked on this sequence focusing on two main subjects. The first one were the hero assets, our spaceship Zion, which had 3 different state variation: the clean one, the damaged, and the wrecked one. This spaceship should switch between those different variation during the sequence, but also during shots. So we created USD layers, one per state, and make the switch happen in our assembly scene directly in render level. And we actually did the same for the hundreds lights that were on each variation of this on this spaceship. So artists could work on the sequence without thinking about which state should be on that shot or that shot. These assets were also FX dependent, with an energy shield that should turn off or turn on during the sequence, thrusters on it, and of course the asteroid that collapsed on the spaceship. The second main subject of the sequence were the asteroid field itself. We wanted a sense of infinite to that environment, so we ended up building a 360 environment by modeling procedurally asteroid in SOP. Then we created small set dresses and add volume to each set dresses. We then instanced those set dress all around the environment. And working like that gave us the flexibility and the control on the density of the field, and we could also work more easier on the layout at sequence level, but also work on the composition of each shot. We, on top of that, scattered volumes all around the environment to help blend everything together, emphasize the sensation of depth, volumes, and to help set the scale of our environment. We use the same process for lighting. For our dynamic lighting, we scattered several lights all around the environment, and then we were able to play with them with custom AOVs later on in compositing. So overall, using Solaris on this type of project that were focused on environment, but also that have a wide range of VFX elements to handle, were actually a key for us, because it brings our generalist graphics to Houdini and Solaris in particular, and it confirmed that using Solaris in that type of project could become our standard. So I think that's all for me. I will give back the mic to Antoine for some final words and for the Q&A.
Thank you, Thomas, and thank you, Julien. So I think we don't have a lot of time, but
yeah, that's true.
Just to finish, what's next? What are we planning for our future? We would like to build an open PBR-based library, thanks to the improvements made in Houdini 21 and by the Academy. And we have to enhance our existing custom tools. We always have to do it between the shows. I just want to thank our amazing CG team for their hard work these last years, and for our developers, Damien Carodren and Vincent Biot, and to Damien Lagadec and Elliot Thomasson from the Houdini User Group Paris for organizing this wonderful event, and for Azad Dusbaronian from Wizards Digital and for his students. Thank you. Bye bye.